So this is part 2 of an introduction to limits. It is a continuation of the previous video. Let's just recall the steps that we've learned in the previous video. In order for us to solve limits, the first thing we have to do is factorize wherever possible. Second step is for us to simplify. If we have any common factors in the numerator and denominator, they can cancel out. And the third step is to make use of the limit by substituting the value for x into the function. Now, we're going to continue with those questions. So this is going to be example 4. Say we have the limit as x approaches positive 3, and the function is x squared minus 9 all over x cubed minus 27. Now, if you look at your numerator, you notice that is the format of difference of two squares. So to factorize the numerator, it's going to be x plus 3 times x minus 3. The denominator is in the format of difference of two cubes. When you factorize difference of two cubes, you have a binomial and a trinomial. The binomial is going to be x minus 3. The trinomial is going to be x squared plus 3x plus 9. Once you factorize, you will notice that there are some brackets that are the same in the numerator and denominator. They cancel out with each other. So now we are ready to make use of the limit. When we say make use of the limit, recall that we take the value of x and we substitute into the function for x. So our numerator is going to be 3 plus 3, and the denominator is going to be 3 squared plus 3 into 3 plus 9. Simplifying our numerator, 3 plus 3 is 6. In the denominator, 3 squared is 9, plus 3 times 3, which is 9. So we have 9 plus 9 plus 9, which is 27. And this fraction can be simplified. To simplify, we are going to end up with 2 over 9. That is because both the numerator and denominator can be divided by 3. So this is our final answer. This tells us that for this function, x squared minus 9 over x cubed minus 27, as the x values approach 3, the y values approach 2 over 9. Let's look at another example. So for example 5, we have the limit as x approaches negative 1, and the function is x to the power 4 minus 1 all over x plus 1. Now, the format of the numerator is actually difference of two squares. Remember, x squared times x squared gives us x to the power 4. So let's open up two brackets. In our first bracket, we're going to have x squared plus 1. Second bracket is x squared minus 1. The denominator, however, has no common term, so that will stay as is. Now, you need to notice that once you factorize this numerator, we still have difference of two squares as one of our factors. So this x squared minus 1 can be further factorized. You need to make sure that the function is fully factorized first before you simplify and make use of the limit. So factorizing is going to give us x plus 1 x minus 1. And we've got the x plus 1 from the denominator. Now we notice that our numerator has x plus 1, denominator has x plus 1. They can cancel out with each other. Now we are ready to make use of the limit. So we are going to take this negative 1 and substitute it into the remaining factors of our function. So in the first bracket, we're going to have negative 1 all squared plus 1. In the second bracket, we're going to have negative 1 minus 1. Now let's simplify each bracket first. Negative 1 all squared will give us positive 1. So we have 1 plus 1, which is 2. We have negative 1 minus 1, which is going to give us negative 2. So we've got 2 times negative 2, which is negative 4. That is our final answer for the question. This tells us that for the function x to the power 4 minus 1 over x plus 1, as the x values approach negative 1, the y values approach negative 4. Let's go on to example 6. We have the limit as x approaches negative 1 and the function is x squared minus 2x minus 3 all over x squared minus 1. Now, the numerator is in a quadratic format, so it's a quadratic trinomial. The denominator is difference of two squares. So let's factorize. Now, just to remind you, and this is something that you learned in high school, when it comes to factorizing a trinomial, we look at factors of the third term, and we need factors that when we multiply, they give us the third term, but when we add, they give us the middle term. Now, since 3 is a prime number, factors will just be 1 and 3. However, we need to multiply and get negative 3. So let's first consider positive 1 and negative 3. Positive 1 times negative 3 is negative 3. However, when we add those two together, we have to ensure that we get the middle term. Positive 1 minus 3 gives us negative 2. So this works out. So one bracket is going to have x plus 1, the other bracket will be x minus 3. Denominator is difference of two squares, so that's going to be x plus 1, x minus 1. We are going to simplify by cancelling out the x minus 1 at the top and at the bottom. Now we are ready to make use of the limit. We're going to take this negative 1 and substitute in place of x. So we have minus 1, minus 3, all over minus 1, minus 1. Simplifying the numerator, we get negative 4. Denominator, we get negative 2. So negative 4 divided by negative 2 is positive 2. That is our final answer. So this tells us that for the function x squared minus 2x minus 3 all over x squared minus 1, as the x values approach negative 1, meaning as they get closer and closer to negative 1, the y values approach positive 2. So the y values get closer and closer to positive 2. Okay, let's just look at one last example. This is going to be example 7. So we have the limit as x approaches positive 1, and the function is x squared minus 2x plus 1 all over x cubed minus 2x squared plus x. Now, you are most welcome to pause the video and try out this problem on your own, and you can check if we get the same answer at the end. Now, looking at your numerator, it is a trinomial that can be factorized. So we're going to place x and x into our brackets. Remember, we said that we need factors of the third term. When we multiply, they must give us the third term, and when we add, we need to get the middle term. Since it is 1, factors of 1 is just 1 and 1, but we need them to add to get negative 2. So we're going to have x minus 1 and x minus 1. Then, looking at our denominator, we have 3 terms, and there is x that is common between all 3 terms. So we're going to pull out x as a common factor. In our first term, we're left with x squared. In our second term, we're left with minus x and minus 2x, and in our third term, we have plus 1. Now, you're going to notice that this trinomial that we've ended up with is exactly the same as the trinomial from the numerator in the question, which tells us that if we factorize, we are going to get the exact same factors as when we factorized the numerator. So let's just go ahead and do that. Remember, the given function must be fully factorized first before you simplify and make use of the limit. Now we notice that x minus 1 at the top and at the bottom cancel out. So what we are actually left with, in our numerator, we are left with 1. In our denominator, we just have x. We're now going to make use of the limit. We are going to take this 1 and substitute in place of x, so it's going to be 1 over 1, and that just simplifies to 1. So our final answer is a positive 1. And what this tells us is that for the given function, as the x values approach positive 1, the y values also approach positive 1.